So welcome to Mouse with Ish. Now this is the binomial formula, okay? Now this is the second method we can use to expand binomial functions such as this instead of using the Pascal triangle, okay? Now there are so many areas this formula can be applied. We want to see how we can apply it in expansion of binomial expression such as this, okay? Now, let me start by explaining to you how this formula is being used, okay? Now, if you look at it, it says sigma n combination r a raised to the power of r b raised to the power of n minus r. Now, this sigma simply means summation. Now, you can see that there is a number r is equal to 0 written below this symbol, and then there is an n on top. This is simply telling us that the value of r ranges from 0, 1, 2, down to this number on top, which is n. So that is to say that if probably here is 5, then it's telling us that the value of r will move from 0 to 5, which means that the value of r will take 1, 0, 1, 2, 3 down to 5. Okay, so that is what this formula is all about. Let me go back to my original n. Okay, so another thing we have to note is that this combination, this n r in a bracket, this is combination. Sometimes it is written as n and then CL. So these two things are the same. And if you haven't learned combination and permutation, you may not understand what we're doing. But this stands for the formula n factorial divided by n minus r factorial r factorial. So when you have all this information, then applying this to expanding binomial expressions becomes very easy for us to do. Okay, so let's start. Let's see how we can expand this using this formula. Remember, this sigma simply means summation. It's just an instruction that's telling you, as you take these formulas, begin to add them. Okay, so this is just an instruction on how to apply this. So let's go. Now our n is still n. I'm starting with this first r equal to 0. So our n, we're going to have n combination 0. I'm starting, remember this arrow takes the value from 0 to n, like just as I have highlighted here. So first of all, I'm taking this when r is 0. That's why you're seeing this is 0 now. A raised to the power of 0, b raised to the power of n minus 0. I'm done with that. You apply your instruction plus, you take the next value for r, which is 1. So that gives us n combination 1, and then we have a raised to the power of 1, then we have b raised to the power of n minus 1. I'm done with that. You apply the instruction again, plus I'll take when n is equal to 2, and that gives me n combination 2. Okay, then a raised to the power of 2, and then b raised to the power of n minus 2. So this is how we continue to apply the formula. So the next one after 2 is 3. So we're going to have n combination 3, a raised to the power of 3 times b raised to the power of n minus 3. After 3 is 4, plus this sigma is what we are applying. That is this summation, this addition you are seeing. So this, like I said, this is just an instruction. And then we continue till we get to the final, which is what? Which is n. N is what? We get to n combination n, because the last value of n here, okay? And then we have a raised to the power of our r is n, then b. So we get to the point where, because our last value for r is n, so we're going to have n combination n, and then we have a raised to the power of r root n r is our n, and then you have b raised to the power of n minus n. So this is how to apply the binomial theorem. So let's stop here for now. In my next video, we are going to see how we can apply it to solving some problems. Okay, so thanks for watching. Do have a good day. Don't forget to like this video, share it, and follow our page if you haven't. Have a good day. Bye.